Example. Okay, particle moving along a straight line according to the VT graph shown. Given that s equal to 20 meter at t equal to second. Okay. First, determine A when t equal to 7 second and plot the graph. Okay. You are required to find the acceleration at 7 second, which is at here. Okay. What is the 7 second? What is the acceleration? No, from here. What is the acceleration? And you need to plot the AT graph. Second one, calculate the displacement s when t equal to 10 second. Here, 10 second. And total distance travel. Okay, so in order to do that, firstly you need to be able to determine the time at important position. Let's say here we have change in direction. Here we have 15, 25, 10, but here when you change direction you don't have time. So you have to first determine the t at this point. Okay, ta. So from this graph, ta, what I'm doing is now we have here a triangle up there. Okay, and then another triangle here, or you can have a big triangle like this one. So we use this triangle. So I'm using ta minus 0. Okay, ta minus 0 divided by 0 minus where is my ta? Divided by 0 minus 10. Okay, ta minus 0. Okay, so what I'm trying to do is to take this m, okay, because it is same from here and to the overall components. I'm ta minus 0 divided by this one is equal to 10 here, 10 minus 0. Okay, the time is 10. No, 10 is here, minus 0 here, because we have this delta x divided by 10 minus 10. Okay, so x divided by y here, and then I have this small x divided by y. So by using this one, I can have the ta equal to 5 seconds. Okay, and once you have the t equal to 5 seconds, you should be able to draw the AT graph. Okay, first what you need to do is here. Okay, so let's say from here. Okay, from here. Okay, so from here you should directly be able to draw the AT graph, which is this is increased steadily at positive line, so it should be positive value. This is constant, so the A is 0. This is this decrease, so A will be negative value. That should be a graph. AT. Okay, you should be able to draw that. This is say you add 1 and here is A2. You didn't know the value of A1 and A2, but the graph is correct. You should be able to draw this one. Okay, with the time given is 25, 15, 10, and so on. Okay, so that's how I draw this graph. A1, A, and the other component. Okay, so now based on this graph, okay. So we have this graph, A1. Okay, so what I need to do is area under graph for this one. Okay, area under graph equal to delta V. Okay, so the way I calculate is 10 minus 0. This is from here, minus 0 times this length times A1 minus 0 equal to delta V. So in this case, this is delta V. V here is from negative 10 to 10. So that's why here I'm putting 10, which is V2, minus negative 10. Okay, let me draw it here for... Okay, so... Okay, this one. So we take it from V2 is 10 and V1 is negative 10. So we have this one from that calculation, we have VA equal to 2 meter per second. This is A1 equal to 2 meter per second. Okay, so another part is 0, so you need to go to this part, which is this last one. Okay, so you will need to have this equal to delta V. So A2 times 25, this one 25 minus 15 equal to delta V, which is the V here is V2 is 0, V1 here is 10, so minus 10, so you have A2 equal to negative 1 meter over second. So you have the value of A1 and A2 and plot graph. So you answered already the first question. Okay, so go to the second question. Displacement S at t equal to 10 seconds. So in order to do the displacement, you need to be able to draw this graph first. Okay, able to draw this graph, and then you can calculate the displacement. Okay, let's say this graph increase from negative to positive for velocity, so you have this. Okay, so that you will have this graph. Okay, so where to start, at 0 or where? Okay, for this particular question, it is already said to you this one at s equal to 20, at t equal to 0, s is already 20 meters. So here I need to draw exactly start from 20 at the beginning. Okay, so I'm this one going down and upward. The minimum value here is at this one 0, so this one 0 must be minimum, so going minimum, going upward. Okay, then constant like this one, so you have a constant increase, so this is constant increase, decrease but in positive region, which is this one, so you should take this part going this one. Okay, so now you have the graph for ST graph. Okay, so what you need to do is area under graph VT is delta S. So this is area under the graph. Okay, this is all equal to delta S. What you need to do is need to do segment by segment. For example, here I'm doing OA, AB, this is B, right? B, C, D. So OA, AB, BC, and later on we go to DC and CB and so on. Okay, AB, OA, AB, CB, and DC. Okay, OA, AB, BC, and CD. Okay. Okay, for OA, let's say for OA, we have this area under graph, half time this length, which is, we know that this is 5 times 5 times this is 0 to this is 10, and I'm putting directly the negative because this area under graph is negative part. So I'm putting it as a negative, equal to delta S. This is delta S, meaning that S at A minus S at O. So it said that, so this is 25 from here. SA would one we didn't know. SO is given from the question. Start from the beginning. S equal to 20. So you get the value SA equal to negative 5. So from the graph, you know that it start from 20 and go to negative 5. I think maybe okay, so here you see this is not the 0, this is my 0, down here 0. Okay, because this is here the 20. Okay, so from here, no. Okay, start from the first one, SA equal to negative 5, and you can continue by this one. You take this another half here from CAB. Okay, so 10 minus 5, so you have 5. The length here 10 minus 0, so you have 10, half because it is triangle. Delta S, SB minus SA. So SB, the one we didn't know, SA is from here, so SA. From this one you get the SB. Okay, so SB is equal to 20. So again it is go up, go down 95, go up same level to 20 SB, and then continue by doing on BC, which is this part on BC. So 15 minus 10, 15 minus 10 times 10. There is no half because it is a triangle. Equal delta S SC minus SB. SB we already know. So from here we can get SC equal to 70. So here is the SC. You do the same thing for SD. Okay, for SD. Okay, you do the same thing, which is half, and then the triangle is 25 minus 15, so you have 10. The length here is 10 minus 0, which is 10. Okay, this one equal to delta S, which is S at D minus S at C, which is 70. Okay, so here is the calculation. Okay, so from the calculation you can get SDD equal to 120. Okay, SDD equal to 120. Okay, so put it in one. You want to have the distance travel. So now you need to do is you need to draw the path from okay the particle. This is reference point. Start from 20. This is 20. Okay, and then goes to -5, meaning that it goes opposite direction, and stop and change direction at -5 and 15, -5, and then go straight until it stop at 120. Okay, so goes there. So the distance travel is all this length be your distance travel. So I already draw it there. Start from 20, going back and up, go top at 120 here. So the distance is 20. This is 20 plus 5, you get 25. And here is another 25 from here. And from 20 to 70, you have 50. And 70 to 120, you will have another 50. Okay, so 25, this is from here. Okay, 25, 50, and the distance ever is 150 meter. Okay, so that's all for this one. So what you need to do is you need to be able to draw the graph from any given. Let's say you given V, you need to be able to draw the AT and also ST graph, and then you will use this graph that area under graph VT will be delta S, area under graph AT will be delta V. Area under graph is between this line, okay, 0T and graph itself. And other thing is you need to calculate area under graph separately, meaning that check the part by part, that like I've done that here. OA, AB, BC, and CD. You can go straight forward because here from O to A you have one component, A to B and another component. Okay, another type of graph, here another type of graph, and the other one. So you need to go one by one, and at the end you can calculate the S or V depend on the graph. Okay, so that's all for area under graph method.